Microsoft Azure Machine Learning allows you to use R code in any experiment. You can take advantage of extensive, familiar, open-source R libraries in your existing analytics code. To use R in an Azure ML experiment, you need to use the Execute R script module. Let's try it. Just paste your R code into the script window. We'll use an existing sample dataset, the adult census dataset. It has features such as education, gender, and marital status. In this example, we'll try to predict if a person's income is greater than or less than $50,000. First, let's connect the data to an input port. Note that the R module has 3 input ports, 2 for datasets and a third for zip files, so you can load additional R code, R packages, and datasets. Now that we've connected our dataset, we can use that dataset inside our script. Using the map input port function, we'll map the first port to the dataset1 variable. Since we don't have a second dataset, we can delete this line. Let's also get rid of the sample code that is in the script by default. Let's do some simple plots of the data. Azure ML comes with many R packages already installed, but it's easy to add more. We'll need the ggplot2 and data table libraries. We can add those libraries as we would in RStudio. First, you need to clean up some of the names of the data columns so that we can use them in our R code. The dataset uses a dash pattern, and we can replace it with a dot. Next, let's make a few histogram and density plots using the gplot function. Set the output of the gplot equal to foo, and then we can print foo. By doing this, it will print the plot to the second output port, which is for R console output and graphics device output. The other output port is for the results dataset. Let's change the code to output our data with the updated column names. Let's see what this looks like. You can see we have all the plots that we created just as you would see in RStudio. We can also create new features in our dataset. Let's create a new dataset and add average age by occupation and age as a ratio of average by occupation. Let's output the new dataset. You can see we have 2 new columns, and we can see basic statistics, min, max, standard deviation, and the histograms for those columns. Next, we need to train a model. First, we have to choose an algorithm. We want to do a classification problem. Let's try 2-class-boosted decision tree. We need to split our data so that we can save some data for testing. Then we need the train module to connect the regression algorithm and the data. We also need to tell the train module which column contains the label for our data. Remember that we are predicting income, so this is our label. Next, we want to score the test data that we held out using our trained model. Finally, we want to see the metrics such as AUC to determine how well our model did. Now we are ready to run the experiment. We can look at the results of the scoring. This algorithm predicts the probability that the result is greater than 50K. A probability over 0.5 is labeled as greater than 50K, and less than 0.5, less than 50K. Now we can visualize the metrics for the scores. We've got the standard outputs like the confusion matrix and accuracy. The AUC is 0.92, which is pretty good, but we could go back and try to improve the results by trying different parameters with parameter sweeping or trying different algorithms. Once you are happy with the results of your model, you can create a web service. Next, we create the scoring experiment. This simplifies our graph for publishing. We run the new graph and then publish the web service. Now we have an API that we can call, passing the features for a person to predict whether or not they make more or less than $50,000. Thanks for watching.